Hi everybody, today we're looking at adjacency matrices for directed graphs, which we also call digraphs. We'll look at constructing matrices for these relations. An adjacency matrix is a matrix used to represent a relation on a finite set. It contains the same information as the digraph, but organizes that information into rows and columns. To construct an adjacency matrix, we'll start by labeling the rows and columns using the same elements of the set and keeping these elements in the same order. Then, if there is an arrow from A to B, we're going to place a 1 in row A, column B. If no arrow from A to B exists, we're going to place a 0 in row A, column B. Let's walk through a couple of examples. We'll start small with only 3 vertices, A, B, and C. Start by noticing that we have 3 directed edges. That means we're going to have 3 1s in our matrix. We have an arrow from A to B, which says we put a 1 in row A, column B. Then we have an arrow from B to C, so in row B, column C, we put a 1. Our last arrow goes from C to A, so in row C, column A, we put our last 1. Then we put zeros for the remaining entries in the matrix. Our second example has 4 vertices, 1, 2, 3, and 4, so we start by setting up our matrix with 4 rows and 4 columns. Notice that each of the vertices has a loop. We have a loop at 1, 2, 3, and 4. This means we'll have 1s along our diagonal. This maps 1 to 1, 2 to 2, 3 to 3, and 4 to 4. Then we have an arrow from 1 to 2, 1 to 3, and 1 to 4. So we put 1s in the remaining entries of row 1. 2 goes to 3 and 2 goes to 4, which means we put a 1 in row 2, column 3, and in row 2, column 4. 3 goes to 4, so in row 3, column 4, we put a 1. 4 only maps to itself, so we don't have to add any additional 1s. The rest of the entries in the matrix will again be zeros. Our last example has 6 vertices, A, B, C, D, E, and F. So we'll have 6 rows and 6 columns in our matrix. We'll start by looking at vertex A. A goes to B, A goes to D. So we have 2 1s in row A. Then B maps to D, E, and F. So we put 3 1s in row B. C maps to B and to F. So we'll add our 2 1s in columns B and column F. D maps to A, so we add a 1 in row D, column A. When we look at vertex E, I want you to notice there are no directed arrows coming from E. So row E won't have any 1s, it'll only be zeros. Our last vertex F only has 1 directed arrow, which goes from F to C. So in row F, column C, we'll add a 1. To finish up, we'll add zeros in all the remaining places, which gives us our finished matrix. Remember, when you're working with the adjacency matrix, it contains the same information as the digraph. It just organizes that information in a different way. As you practice, focus on matching arrows in the digraph to the corresponding row and column position in the matrix. In the next lesson, we'll see how matrix representations can help us determine whether a relation has important properties like reflexivity, symmetry, and transitivity.